Hey, Tayson here. So, I was originally gonna make an entire video with an animation section to it, but unfortunately I didn't have time due to working on Mrill and internshipping to Ceylon Studios alongside doing my SATs and end of school year studies. So, unfortunately, Baku, I couldn't make a video. So, yeah, I'm just gonna explain my genome now. So, base genome is camel spider. So the camel spider is a very good build. It's very compatible with different environments. Not only been found in deserts, but also plain and also forest biomes. So this is very compatible with the remaining biomes in the hybrid war, or at least this war. Also being a very fast build, also moving at 10 miles an hour. But more conservative estimates gave it 6 to 7 miles an hour. Next is Portia spider. So Portia spider is there for adjusting the limbs. The limbs of the camel spider is very long. So a Portia spider just modifies it so it'll be more springy. So the spider could be able to jump on surfaces better. Alongside that, we're giving its eyes. So its eyes are very sensitive to light. So you can see here it has 8 eyes. We'll give it its 8-eyed structure alongside with its head, some modifications to the head. So it could accompany that many eyes, alongside making the head bigger to ratio, so it could have like a bigger brain. So yeah. Other than that, we're giving its hairs, so its hairs are more for motion detection. So it'll be able to sense if a hybrid sneaks up on it or be able to tell the wind and the environment around it. Speaking of the environment, porgy spiders are very intelligent spiders since they have very well spatial awareness. They use their hairs and high intelligence to even calculate where they would jump to or calculate their jumping distance. Other than that, they have been also to be able to do pranks or tricks and are very intelligent. They're one of the most intelligent insects also. So yeah, they do actually are able to learn trial and error. So yeah. Okay, next genome is Transval thick-tailed scorpion. Okay, so the Transval thick-tailed scorpion is one of the more essential genomes in this hybrid. So the Transval thick-tailed scorpion is here for its tail and stinger. So what's so special about the thick-tailed scorpion? They're one of the known scorpions to be able to shoot their venom. So this is a diagram showing how venom is shot from a scorpion. So the venom sac, we won't take its venom, but we'll take its venom sac and tail. It has been documented to shoot from 1 to 3 feet away from it. At this scale, this is way bigger than the average Transval thick-tailed scorpion. Our hybrid, the final result is 100 grams. So the end result will end in our hybrid being able to shoot 1 meter at least, at minimum, when shooting this. Okay, next genome is the Darner dragonfly. So the Darner dragonfly is here to modify most of the eyes into compound eyes. Compound eyes are able to process more information. It has a higher light flicker fusion, so higher reaction time, and higher information to process. So this would be useless if I didn't modify the optic lobe on this hybrid. So we're actually scaling up the brain with this, since higher brain to body ratio. So yeah, this is a thing you could do with hybrid since you can make it bigger, and you could also take the brain to body ratio. There's nothing wrong with this. So we're taking the brain to body ratio alongside making its optic lobe way larger in the hybrid. So it'll be able to calculate its opponents. If you don't know, dragonflies are able to predict their opponents, predict their prey. So that's why dragonflies are known for having a 97% win rate or successive hunt rate. So yeah, this will be able to make our hybrid be able to dodge any attacks or even calculate any future attacks. Next is desert locusts. So desert locust is here for several things. Mostly it's spiracles. So if you didn't know, spiders are arachnids, and arachnids don't usually have spiracles. They have book gills, book lungs. We'll still keep the book lungs, but modify most of them alongside the abdomen and maybe the tail to have spiracles. So the spiracle of the desert locust is very robust since it gives oxygen immediately to the muscles. Unlike other arachnids, this arachnid, I'll call him Conti, Lord of Black Flames, you'll get the reference, or Arachnid V2, depending on what you want to call it. So the desert locust here, the spiracles will give oxygen immediately to the muscles. So the muscles would be able to have more fuel, making our hybrid more durable, and could be able to run faster for longer and exert more force in its attacks. Under this, we're adding its lipid stores. Lipids are fats. So this is how desert locusts, they could be able to fly over deserts for days on end due to their high fat stores, alongside their spiracles too. So this is all like stamina. Next, it's its resilient layer in the epicuticle. So what is the epicuticle? The epicuticle is near the joints or a specific layer of the exoskeleton. So resilin is this material that is very springy. The equivalent of this in humans is collagen or your joints. So we're adding layers of resilin alongside the exoskeleton and concentrating the limbs to make it springy. So desert locust has like very thick layers of resilin compared to other arthropods. Other than that, we're taking its hind limbs too. So we're modifying the hind limb of a spider into becoming the jumping limb of a uh, locust. So this would help the Porteous spider in instincts to jump. So you say, oh, they would overjump, but no. The thing is that like animals are able to adapt to any situation. So if they know they're gonna jump that much, they're gonna calculate for that much. So this is just makes our hybrid be able to escape faster from like its opponents and also be able to move around faster. Okay, next contributor, black fire beetle. So black fire beetle is a very weird choice. It's here for only two things. It's a light flicker fusion rate. So a light flicker fusion is basically how fast your eyes can process light. So animals with higher light flicker fusion rate might see things in slower motion. So that's how flies, they could react to even birds and humans trying to catch them. Animals with higher light flicker fusion are able to keep up with flies, like the pied flycatcher, which has a light flicker fusion of 146, and are able to catch flies. Dragonflies are able to react to other invertebrates and animals due to having over 200 light flicker fusion rate. But the black fire beetle has 300 to 500 hertz in its light flicker fusion rate. That means our hybrid will see things in slower motion and be able to react to even maybe surprise attacks and maybe head-on attacks too. Under this, we're giving our hybrid a higher olfactory bulb. The black fire beetle is known for having a very strong sense of smell, but not only just smell, but even detecting heat. It has a form of heat vision or heat detection in its olfactory bulb. So they've been found to actually be attracted to a stove since they could detect the stove. We won't take its instincts to find fire, but we'll give it its olfactory senses to know what fire is or heat is. This will be explained later why this is important. Next is vent crab. Okay, crabs have like very weird anatomy, but here's the thing. Let me get the details. Vent crabs here are for three things: modifying the jaws. So the jaws of this camel spider are actually claws. I forgot what they're exactly called, but we're modifying the jaws and even the limbs, giving its tunofilaments. Tunofilaments in crabs are the see-through parts you see when you eat a crab, right? And that basically is muscle attachment to the limbs for a crab. So this will increase bite force and even limb strength in our hybrid. But any crab has that. So why the vent crab? The vent crab has an exoskeleton that is made of chitin, but other than other arthropods, it prioritizes calcium carbonate. It has a very strong exoskeleton that has heat shock proteins also. It is very heat resistant since vent crabs live near vents. So vent crabs actually have an exoskeleton strength of 7 GPa. you want something to compare, the scalyfoot gastropod only has 6 GPa strength in its shell. So our hybrid will actually have very compatible armor that's made of calcium carbonate that is semi-mineralized, since we're not in the ocean, so the mineralization would come from like its diet mostly. So yeah, this is very shock. This is very heat resistant armor that's harder than even scalyfoot gastropod. Next is bombardier beetle. I hear you say, "Oh, the bombardier beetle, I can't get shell." Okay, shut up. So we're using its glands for hydrogen peroxide, but not just that. We're taking its glands for hydroquinone. So hydrogen peroxide would have its own gland. Hydroquinone would replace every single gland. So see here, hydroquinone. The glands for hydroquinone will be allocated to the scorpion's venom sac. You see here. And only the venom sac. So hydrogen peroxide would be dealt later. So yeah, this is the hydrogen peroxide. Oh, wait, I forgot one contributor. Let me add it in. I did forget the photo. Where is it? Where is it? Yeah, sorry. The cuttlefish. So why the cuttlefish? The cuttlefish is here for one reason. It's ink sac. So the ink sac, talking homology wise, would grow from the ass, the butt. So the fictile scorpion, its anus is actually not in its stinger. It's actually behind the stinger. So pretend you have this region here. This part. Let me get it. This part here is where it craps. This part here is where it stings. So the hydroquinone would go through this tube instead, but the squid ink would go through here. So instead of having squid ink, we're only having the sac, and the sac would produce hydrogen peroxide. We'll explain later why this is important. So the cuttlefish is different from other mollusks since its ink sac actually absorbs a lot of its metabolism. 50% of its metabolism is just dedicated to creating ink. We'll take this allocation of metabolism to the ink sac, so this hybrid will optimize producing hydrogen peroxide. So yeah, next contributor is the fire ant. Okay, the fire ant here is for its robust immune system. They have a very good system against parasites, and also a very good immune system against other venoms or even, let's say, diseases. But like, we're taking its Dufour glands. Dufour glands are basically glands that are connected to the stinger. We're taking the Dufour glands of the fire ant and allocating it to the ink sac. So the Dufour glands in fire ants produce alcohol, acetone, and some different chemical that is irrelevant to the conversation of currently. We'll modify. So we're modifying the Dufour gland to only produce acetone. If this is against the rules, we'll also take the Dufour glands with the alcohol and other chemicals. So why the Dufour gland? So the acetone is very important, since acetone mixing with hydrogen peroxide creates acetone peroxide. What is acetone peroxide? Acetone peroxide is an explosive chemical. So in liquid form, it's more stable than its dry form. So this hybrid won't kill itself. It has to have high temperatures to ignite it. So hydrogen peroxide, acetone peroxide, has been made accidentally. This is very simple mixing. Sometimes people will drop acetone onto hydrogen peroxide and it will mix. So yeah, this is a very simple mixture process. This does not need a lab to create. So yeah, next, this is a very simple chemical. I do not want to stress this enough. This has been made on accident and has been made unintentionally. So I think having it in one single sac and it mixing each other is good enough. I do not care of the other chemicals in the four glands of the fire ant, Since it also has acetone peroxide has been able to be compatible with alcohol and the other chemical, maybe even helping the chemical reaction. So next is the carpenter ant. The carpenter ant has glands to produce formic acid. Formic acid is a low pH acid reaching from 1 to 1.5. It uses it for its venom and sometimes defense. So we're taking its acid glands. It'll be able to shoot it from 50 to 70 centimeters away. This would scale up higher in a hybrid. But the acid here would also be added to the ink sac. So why acid in hydrogen and acetone peroxide? So when it mixes, it creates a chemical called triacetone triperoxide. It is a explosive chemical that is 80% the force of TNT. So acid, but we have to mix in the acid. But no, acid automatically reacts with the two chemicals. It'll actually make the two chemicals mix with each other, creating a compound, as I say, TATP, also known as the mother of Satan. So this would be mixed in the hybrid, and it'll have an explosive that is in the ink sac. It'll have like an ink shooting mechanism from its tail. Other than that, we'll take its ocelli. Ocelli are like false eyes on an ant. It is used for controlling hormonal regulations and sleep patterns. So yeah, this is just like more sensory to our hybrid. So this is the final results. This is Arthropod V2, which I call Conti. So Conti here, this is general build. You'll see. I forgot to mention peacock mantis shrimp. Yeah. There's also peacock mantis shrimp. It's here for its pair of eyes. So you can see here it has mantis shrimp eyes, which I could explain have trinocular vision and could be able to sense different spectrums, 17 spectrums of the color wheel, or like color spectrum. Humans only could see trichromatic colors. Mantis shrimps could see up to 17. So mantis shrimp eyes are trinocular in each single eye, not just both of them, but one of them, singular. So this would help our hybrid have very strong depth perception and be able to process information better. Alongside that, it's also here for its raptorial clubs. We're taking away the spider's pedipalps and replacing it with the mantis shrimp clubs. So why? So our hybrid has a strategy of shooting out its chemical. You see here, this is general build. So this is hydroquinone, would be shoot from the venom gland. So the TATP sac would be allocated around here to here. So the hybrid would actually shoot out its ink out to here. So you see here, it'll be shot out through the anus. So yes, so this is how it will shoot. The hybrid would like be intelligent enough to know, shooting one chemical and the other would create an explosion. So it could be used for as a defense mechanism or a last resort defense mechanism. This hybrid on its own could combat other hybrids. Since like shooting hydroquinone or just TATP, TATP is very irritant to other animals. TATP alone could cause damage. So TATP has hydrogen peroxide. Hydrogen peroxide compounds react with hydroquinone compounds, which create heat up to 200 degrees. TATP has been found to explode in 50 Celsius conditions. So this is way above the limit of how TATP would explode. So yeah, this would actually burn its opponents alive. So to continue, this is the general strategy of attacking its opponents. Maybe if it starts getting cornered, or it sees, I could get the kill instantly, they will shoot out the TATP. The TATP is metabolically taxing. That's why we're sending it to Section B, the Plains biome. The Plains biome has enough resources. It has grass, which this hybrid could process since it has ant DNA. It has like small animals and a tree, an olive tree to be exact, which this animal could climb onto since its limbs are modified by locusts and dragonfly that have hooks on them. The hooks would allow them to hook onto bark, leaves, and then it'll have an easier time scaling these environments. You can see from its limbs here. So about like its vision, it has mantis shrimp eyes, compound eyes, and O'Shelley to help it process information. So it'll be almost impossible to even sneak up on this hybrid or even outreact this hybrid, since it has a light filter fusion of 300 to 500 hertz. So the general strategy is already established. This is the end of my presentation. So yeah, this is Conti, Lord of Black Flames. It's a reference to Fooly Cooley. And yeah, Arthropod V2. This is my hybrid, and you could look at it more. Unfortunately, I cannot design it more. I would like to do more art, but unfortunately, no. It'll probably move around 15 to 20 miles an hour, depending on conditions and environment. Also, I forgot to mention what animal gives its size. I'm taking like the vent crab to up its size a bit. The vent crab is like more than 100 grams, but it's the largest animal that surpasses 100 grams, so we're just modifying, tweaking the gene slightly so it would reach the 100-gram limit. My hybrid would be quite long. I would say around 10 to 20 centimeters, depending. I haven't established this yet since the calculations aren't done. But this hybrid would probably be slightly shorter than other spider hybrids around the same size, but much longer due to scorpion tail. Other than that, it'll use its jaws to attack sometimes, but mostly its ractorial clubs and using its agility to escape, since it has like very good sensory hairs. Yeah, this is a genome explained. I think it has like very good matchup against the opponents there, since birds can't outreact this in a plains biome. This might actually end in my hybrid just burning down the entire place. Since TATP, from videos I found, it actually burns on wet grass. And this is a dry plains, so this might actually burn up the entire plains. My hybrid could probably avoid the fire, since it has like better senses to detect fire than most hybrids. And that it could like move around the environment faster than all land vertebrates that are in this competition. So yeah, this is the end. Thanks for listening to my TED Talk.